Chapter 7, Ratio and Proportions. A ratio compares two numbers by division. For example, 2 to 3, 4 to 7 compares two numbers by division. A proportion is an equation stating that two ratios are equal. For example, 2 over 3 equals x over 8 would be a proportion. Two ratios that are equal. In a proportion, for example, if we had the proportion A over B equals C over D, there are things called values that are extremes and values that are means. In this example, A and D would be your extremes, and B and C would be your means. The extremes are in the first and last position, and the means are in the middle positions. The last kind of vocabulary word we need to talk about are the cross products. The cross products are the product of the extremes and the means. For example, in the proportion above, the cross product would be AD equals BC. All right, the next word we're going to talk about is the word ratio. We're going to go back to that word. A ratio compares two numbers by division. We talked about that already. The ratio of two numbers, A and B, can be written in many different ways. One way you can write A and B is as a division. Another way you can write it is with the word 2. And another way you can write it is with a colon. Those are three different ways to write a ratio. Write a ratio expressing the slope of the line. In order to get the slope, you use the slope formula, y2 minus y1 over x2 minus x1. So we pick a y value, 5, minus the other y value, 3. Go back to your original point, use that x value, 7, minus the other x value, 3. And then simplify. 5 minus 3 is 2. 7 minus 3 is 4. If you reduce that, you get 1 over 2. So the ratio of the slope of this line is 1 over 2. You can write that in many different ways. One way is 1 over 2. One way is 1 colon 2. And one way is 1 to 2. The next one. Write a ratio expressing the slope of this line. This time the points are not on a coordinate plane, but you still do it the same way. So the first thing we're going to do here is we are going to find the slope. So I picked 5 as my original y value, minus my other y value, 3, over my x, 6, minus my other x, negative 2. 5 minus 3 is 2. On the bottom, two negatives make a positive. 6 plus 2 is 8. If you reduce that, you get 1 over 4. The next example we are going to talk about deals with ratios. It says the ratio of the side lengths of a triangle is 4 to 7 to 5, and the perimeter is 96. What is the length of the shortest side? First thing I'm going to do is I'm going to draw a triangle to represent the situation. Whenever you have a ratio, it is not the length of the sides, but is a correlation between the lengths of the sides. So you must include the variable x. In order to get the perimeter, you then add up all the sides. 4x plus 5x is 9x, plus 7x is 16x, and then you set that equal to 96. Once you get that, you divide by 96, and you get x. In this situation, 96 divided by 16 will get you the number 6. And then once you get the number 6, you are going to plug that value in for the shortest side. If you go back to your triangle, you then plug 6 in for x in your shortest side. 6 times 4 is 24 feet. Let's try another example. The ratio of the side lengths of a triangle is 2 to 4 to 5, and the perimeter is 55. What is the length of the shortest side? We again are going to draw a triangle to represent the situation. We're going to label our sides. Because it is a ratio, it is a correlation among sides, so you need to include the variable x. You then get the perimeter. We know our perimeter is 55, so we are going to add up the sides. 2x plus 4x plus 5x gets you 11x. If you divide by 11, x is 5. And again, we need the shortest side. We then plug 5 in over for our smallest side and get 10. And there's our answer. All right, if you can flip your page. On top of the next page, we are doing something very similar, but this time instead of the perimeter, we are actually talking about angles in a triangle. So if I draw a triangle according to the problem, the ratio of the angle measures in a triangle is 1 to 6 to 13. What is the measure of each angle? So inside my angles, I'm going to put a 1, a 6, and a 13. Now my picture is not drawn to scale. I'm just doing a rough estimate at this time. Because it's a ratio, they all need x's. If you add up all the angles in a triangle, you get 1x plus 6x plus 13x, and you get 20x. And all three angles in a triangle add to 180. So you go 20x equals 180, and then solve for x. In this situation, if you divide by 20, x will be 9. In this situation, we are finding the measure of each angle. So the first thing I'm going to do is plug in 9 here. So this angle over here will be 9 degrees. I'm then going to plug 9 in here. And this angle right here will be 54 degrees. I'm then going to plug in 9 over here. And when I do that, 13 times 9 is 117 degrees. And you have your 3 angles of the triangle. Okay, let's try one more of those. The ratio of the angle measures in a triangle is 7 to 13 to 16. What is the measure of the largest angle? So I'm again going to draw a rough estimate of my triangle. Put in my ratio numbers. Because it's a ratio, I'm going to add x's to them. Next thing I will do is we are trying to find the largest angle. We know that all angles in a triangle add to 180. So I'm going to add these up and get 36x equals 180. At this point in time, I'm going to divide by 36, and x will be 5. In this situation, we are just finding the largest angle. I then go back to my triangle and find the angle that represents the biggest one. Plug in 5, 16 times 5 is 80 degrees. The last thing we are going to talk about is your cross products property. We discussed this on the front. And all as the cross products property is you multiply your means and you multiply your extremes and set them equal to each other. So in this case, we would have AD equals BC. In our first example, all we're going to do is solve each of these for the variable using the cross products. So in our first example, x times 56 is 56x. 7 times 72 is going to be 504. If you then divide by 56, X will be 9. In our next example, we cross multiply or do the cross products property. You get 45y equals, multiply the 5 and the 63 and you will get 315. Divide by 45. And when you do that, you get y equal to 7. If you want to know if any of these answers are correct, you may plug them back in the proportion and make sure they are equal. Our next example, we would have 8x equals, if you multiply 3 times 56, you get 168. Divide by 8. And when you get your answer, when you divide by 8, you get the answer of 21. Our next example is a little bit more difficult because it deals with more variables, but you still complete it the same way. So in this case, I would go 9 times 8, and I would get 72. I would go 2y times 4y and get 8y squared. And then I would solve this equation. First thing I would do is I would divide by 8. 72 divided by 8 is 9. And then in order to undo a square, you would square root. And when you square root that, you get 3. But whenever you have a square, you have 2 possible solutions, and it is the positive and the negative. So in this case, your answer would be plus and minus 3. Our next example is similar to the one we just did. We're going to cross multiply. 10 times 4 is 40. X times x is x squared. In this situation, we don't have to get rid of a number out front, so we go straight to getting rid of the square with a square root. It does not say to leave it in simplified radical form, so you can leave it as a decimal. If you square root 40, you get approximately 6.32. And because of the square, there are 2 solutions, the plus and the minus. We have one more example of this kind. So our next example, we are going to multiply 2 times 32 and get 64. We're going to multiply 2x and 2x and get 4x squared. We are then going to try and solve for x. So the first thing we will do is divide by 4. 64 divided by 4 is 16. And then to undo the square, we will square root it. The square root of 16 is 4, but in this situation, it will be the plus and the minus. Our next situation deals with even more variables. So the first thing we're going to do, just as we have before, is cross multiply. So we get 120 equals, and when we cross multiply these, and this should be a z, when we cross multiply those, we have to actually FOIL. So in this situation, what we're going to do is we are now going to take and we are going to FOIL out the right-hand side. So we keep the 120 there. On this side we have z squared minus 4z plus 4z minus 16. If we continue, the plus 4z and the minus 4z will cancel. We are left with 120 equals z squared minus 16. And then in this situation, we just continue on by trying to get z by itself. So the first thing I'm going to do is add 16. So we have 136 equals z squared. And then to undo a square, we are going to square root. So then we have z equal to the plus and the minus of 11.66. And that will be our solution. Our next one is very similar. So the first thing we're going to do is cross multiply. So 4 times 6 is 24. If you cross multiply, x plus 1 times x minus 1, we are again going to FOIL there. So I have 24 equals x times x is x squared. X times negative 1 is a negative 1x. 1 times x is 1x, and 1 times -1 is -1. Once we do that, my two middle terms here again will cancel. So in this situation, I have 24 equals x squared minus 1. We then continue and solve. Going to add 1. 25 equals x squared. And then I must undo the square with a square root. And because it was a square, you will get plus and minus 5 is your solution. Our last example is done the same way. We're going to start by cross multiplying. 6 times 12. And when you multiply 6 times 12, you will get 72. So we have 72 equals x plus 2 times x minus 2. We will again FOIL. We have x squared minus 2x plus 2x minus 4. We will again have our two middle terms cancel, and they will cancel every time you have two binomials that are the same with opposite symbols in between. So we have 72 equals x squared minus 4. We will then add 4. When we do that, we get 76 equals x squared. We will then square root both sides. And x will equal the square root of 76, which is 8.72. So x will equal plus or minus 8.72.